our test case. So let's continue our test case here. So we have created our path, realtime.log. We have created this periodic file writer object out of that path and of this file, and we will keep on writing it using this schedule executor. And inside this, we have also created our JTail object where we are passing this path as a string, and the number of line is 1. And then we set our watch directory to the same folder, resources folder. And now we have got this executor, which will keep on appending this this file. Let's reduce it because we don't even want to wait here for so long. We can, for 5 seconds, we can just wait it for 1 second. So here, let's do it. And now finally, let's call our jtail.tail online method. So this jtail online all again, it will throw a checked exception as IO exception. So yeah, let's do it. So let's revise what we have done so far. If I go back to jtail online, so what we did is that we created a watch directory, which is the same resources folder where we are writing and appending our log. And we are only interested in any modification in this directory. So this modification is that this file is getting appended. So that is the event that is being handled here in this while loop. And every time we don't want to like use this event because not doing with any event. What we are doing is that we are just calling this tail method on a static file, which means that at that time, whatever the content of that file is, realtime.log, will tail that one line, the last line, and then print it. And then the key would be reset, and then we will keep on waiting. So what will happen is that it will be exactly working as a tail -f command in Unix. So in the tail -f command also, as soon as the logs are getting appended, the tail -f will show it in the output one by one. So this is what we are going to mimic here, exactly same. So enough of talking now. Let's actually run this code and see whether it's work or not. So I also got this git bash open here. So if I just do ll here, it will not show anything. So just for your so I will create on this tail command, the actual tail command, which is used in Linux. So I will mimic the same thing here, and then I will also show in the parallel one that how we are doing it in our Java program that we have created. It should be exactly matching, right? So we don't have any real-time dot right now. That's why when I run it here, tail -f, it will show that cannot open because there's no file to read. So let's run our program where our periodic file writer will start writing it, and our jtail will do the same tail online as we are doing it here in the Unix, Linux, whatever, git bash. I'm using git bash here. So let's run this now. I run this. So because there's a delay of a sleep of 2 milliseconds, so at least first 4 lines would be created here. Okay, so let's write. So you see that here our Java version is exactly matching with this tail -f that we run on git bash, which is a mimic of Linux. So you see that this is keep on appending. This is the Java output, and then this is the git bash output. It's exactly matching. And once I stop this, means that this is also stopped, and this is exactly at the same point at 45 line, same as this. And now let's see that in our real-time log is created here, and this is exactly having, starting from the header line, it is having exactly till 45 line. So this is exactly matching. Our jtail method is working exactly same as how it works in the tail -f command and in Linux or Unix or git bash in our case. So guys, this was, I think, very interesting. I think I hope that you enjoyed this problem, that we can also implement our own jtail method in Windows because most of the Windows system doesn't have this tail utility as we have in Linux. So this was all about our problem 6, implement Unix tail command in Java. In the next chapter, we will learn about false sharing. This false sharing is a very common interview problem, which actually the interviewer is trying to learn that how much you know about a threading environment in the multi-core systems. Almost all the production systems are having multi-core, multi-CPU architecture. So this false sharing is very common there, and we should be very much knowledgeable about this false sharing and how to avoid it. So see you all in the next chapter, false sharing.